Okay, guys, on number 4, you're going to start recognizing the pattern here. Remember that we want to follow our rules, right? First, free body diagram. Second, equality statements and graph annotations. And then third, do the math. Okay? All right, so well-labeled diagram, dog. So there's my dog. Let's see, just a second. All right, so the dog runs down his driveway with an initial speed of 5 meters per second for 8 seconds. So this first bit is constant velocity, right? I'm trying to make that look like constant velocity model, right? 5 meters per second. And then uniformly increases his speed to 10. So at that point is when the acceleration starts, right? So then it's like this and like this, right? And so this is constant acceleration motion with the velocity that way. So if the acceleration is to the right and the velocity is to the right, we know it's speeding up, okay? So on our graph, I'm going to kind of say 1, 2, 3, 4, 5, and 10, right? And then maybe 2, 4, 6, 8, 10, 12, I'm getting sloppy, 14, 16, 18. Ooh, that was a little crazy. 16, 18, 20. Okay, so initially we're going at 5 constant velocity for 8 seconds. So I'm just going to come across here to 8. Okay, so that slope equals 0, right? So the acceleration equals 0 here. Now then from that point, I'm going to go for 5 more seconds. So from 8 to what? 13? Okay. So maybe like ish. And I'm going to uniformly increase to 10, right? So I'm just kind of, so I'm going to uniformly increase. Okay, so this is not a line I needed. I was just kind of trying to find my 13 seconds there. Okay, so let's see. So the slope here, if I go from 8 to 13 seconds, so if I go 5 this way and 5 in the y and 5 in the x, then the slope equals 1 meters per second squared. Okay, great. Now, if I want to know how far it traveled in this first part, then I would find the area of the first part. And in the second part, then I would find the area of the second part. Okay? So, so I can find the acceleration and how far just from the graph. Okay, but I sort of am getting ahead of myself. So let's say vertical motion looks to me like in both cases the vertical is balanced, right? Force normal is balanced with FG in both cases, right? The dog isn't levitating or crashing through the plane or anything like that. So that's good. And then, so I guess I could go back here and say the equality in the y for the whole thing is force normal equals force g. Now that won't be always true for the rest of our lives in physics, but for right now our y is kind of simple. So then let's look at this. So initially when it's at constant velocity, we know the forces are balanced, right? So whatever they are, we could say, I'm going to say force traction on dog by ground. Okay? And then over here, I'm just going to say force air. on dog, by air. There we go. All right, so, and I'm going to put a little congruency in there. Those are balanced. That's what's going on here. So equality in the X, F air equals F traction. But if I go to this next place, they aren't equal because it's speeding up. So let's just assume that maybe the air stays the same, but the dog is pushing more because it's accelerating. So I'm going to say that the traction is more. The dog pushes more on the ground, and the ground pushes more on the dog. Okay, so in this case, the equality statement in the X is that F net equals F traction minus F air, right? And all that equals MA. Okay, so if I know any of that, I can work with it. So looking good, looking good. What's the dog's acceleration? Well, I mean, my kind of go-to, I just want to remind you, what do I know? I know V equals AT. These are my kinematics equations. Kinematics is constant acceleration, always. Okay, so V naught, and we know X equals 1/2 AT squared plus V naught T plus X naught. And when things start from rest, then both of those go away. When they start from the origin, this one goes away. Then we know V squared equals 2AX plus V naught squared. This would be a situation where you aren't given time to solve for or to solve with. And then lastly, I believe we said V1 plus V2 over 2 times T gives you X. So these will be the ones we use the most. And the other thing to remember is that all these things say X's because what's happening is all in the X right now. But when we start moving in the Y, then all the X's we can have the same equations if we're accelerating in the Y, but it would be Y equals 1/2 AT squared plus V naught in the Y times T plus Y naught. So that's kind of how that would go. All right, so in this case, I still like that one. So I'm going to say A equals V minus V naught over T. And that's going to be 10 meters per second minus 5 meters per second over 5 seconds. Yeah. So 1 meter per second squared. Oh, look, same as what I got here. Awesome. Confirming. Okay. And let's see, what else do they want? So they want we know that the acceleration during the first part is 0, and the acceleration during the second part is 1. So that's good. All right, so what was the acceleration during the second part? It's 1. How long is the driveway? Well, the driveway has to be whatever distance we covered here plus whatever distance we covered here, right? So it would be, the driveway would be, the X distance covered would be length times width plus this thing, which is all the area under here, which would be the length times width for this, yeah, plus the 1/2 base times height for this part, okay? So for me, I think the how far is easier to find. Let's see, so I think I'm just going to say X equals VT plus X naught, and I'm going to see how far does it go when it travels at a constant velocity. Yeah. So for a constant velocity, it travels 40 meters. So 40 meters should be the area here. And then I want to see how far does it travel when it's accelerating. And so then I'm going to use 1/2 a, so that's what, 1 meter per second squared, t, 5 seconds squared, right? Plus v naught times t. So the v naught was 5 meters per second times t, which was 5 seconds. And we said the x naught, it started from, the origin. So there's no x naught. So it doesn't start 30 meters ahead or negative 30 behind or any of that. So if I do the math on that, then I end up with 37.5 meters, and 37.5 meters plus 40, right, gives me a total x for the driveway. Total is 77.5 meters. And lastly, if I want F net, F net is just MA, right? So we have M and we know A. So, F net equals 20 kilograms times the A was 1 meter per second. So just 20 newtons is F net. I think that's everything.